All right, so we are back. We are going to go into our functions. So go up to your project, go to functions, go to the index, and I'm going to do it right here. Make some room. Ooh. Let's actually do it above this. So what our function is going to be called update dashboard. So we'll do an exports dot update dashboard. That will equal functions dot firestore dot document, and it's whenever we write to our inferenced images that we will want to do it. So what we'll do is we'll use this wildcard, which says anytime any of these images is changed, well, there's change, delete, we're going to say on create. So whenever one is created, we'll have an asynchronous function that grabs a snap and context. Alrighty then. And then when this triggers, we're going to want to say let the data equal snap.data. Then we're going to say the data, because this has all our properties on it, has predictions. And remember, if you want to know what this has, we can go look at our Cloud Firestore and then grab an inferenced image, and you should see overall score, bucket, predictions. We're going to be going through predictions, and for each prediction, we're looking for the score. Score and the label is what we're looking for. So predictions, so we want to make sure is the predictions dot length is even there. If there's no labels, we'll just skip it. And so if that's greater than 0, that's our little check. Then we can say the data dot predictions for each one. For each prediction, we will update the label, and we'll pass in the prediction. And then at the end of this, we need to return. So update the label. Let's figure that out. Updating the label. So this update label is going to be a function as well, where we say update the label. It's going to receive the prediction, and then we're going to say let the label equal the prediction dot label. And just so you can see it, we will console log the label, which will be label. Great. Now, what we're going to want to do is we're going to want to, with this label, we're going to want to update the database. So let's do our database dot reference. The reference will be it's a label, so we can go check it out. Database label stats model 1, and then our label name. So it will be label stats slash model 1 slash plus the label. All right. And then you can do a transaction in a function with label stats like that. So this will run, well, basically we're going to run a transaction. So what the transaction does is it goes and gets the data from this location, and then we're going to be able to update it. And if other ones are coming in all at the same time, this is actually going to preserve order and preserve like the count, so things won't get out of hand. It's really useful, and that's why we're using it. Now the main key here, which took me all day to figure out, is what we need to say is the label stats is not equal to null, because it's most likely going to come back null, because first it checks out the local cache, and it's not going to be in the local cache, so it's going to be null. And that took me all day, so that sucked. Now the current label stats, so you'll be able to see that it's working and debug it if it's not, we'll put right here. Okay, but since it's inside here, it's not going to be null, so we know it's there, which is great. Because otherwise, let's also throw it outside. Current label stats outside, and that'll equal that. Great. And then we can remove that later. Now, once we're in here, we're going to do a few things. We're going to say our current average precision is going to equal our label stats dot average precision. All right, we're going to let our current min equal the label stats dot min. We're going to have our current max equal the label stats dot max. Why does it keep doing that? It's so annoying. So this is not current min, this is min. And then we can let the current inference count equal the label stats dot inference count. Cool. We can do let predictions equal so the predictions are what we passed in. So that's the prediction. And we actually want to get the score. So let's make this the prediction score. And then we can say the prediction score is going to be equal to the prediction score times 100. So we need to make this not a decimal, which is what it comes back as of right now. Great. Once we've done that, we can go ahead and say let the min equal, and we'll do another tertiary operator here, where our current min, if that is less than our prediction score, then we want to use the current minimum. Otherwise, we want to use our prediction score. And then same with the max. So the max will equal our current max. And if our current max is greater than the prediction score, then we will stick with our current max, else we will use the prediction score. Now, what we're going to want to do is we want to grab the average precision. So let's let the average precision equal. Now, to do a moving average, we could either store all the numbers, but we're not trying to do that. We're just trying to store our current average. And so what we need to do is follow a little algorithm here. So what our algorithm is going to be is it's going to end up being, we're going to do an n times a plus v. I'm going to write it out here, and then I'll show you guys. we'll walk through it, /n plus 1. Now, if you want a fun little challenge, go ahead and see if you can write an algorithm to determine the average precision based on what we have. So what that is for us is it's going to be, and this is going to be where n is our new count, a is our old average, and v is our new value. So I'm going to let the average precision equal the current inference count, and then we have to times our current average precision, and then we're going to add our prediction score to this. Okay. Then we're going to divide the whole thing by our current inference count plus 1. Now, the reason this equation works is because we take our current average and we times it. Basically, we're giving it a weight. We're saying, hey, this average is weighted on all these other numbers. And then we're going to add in our next one, and then we just have to divide it. So that is that guy. And I like to put parentheses around him. One more there. Excellent. So now we have an average precision. Just a few more things to go here. We're going to let our, I'm going to call this the hist, which will be short for histogram. And that's going to be an object. It's going to say over 90 label stats dot over 90. Otherwise, we'll have an over 80. And what we're doing here is we're just trying to figure out which one to use. Label stats dot over 80. Because when we do the transaction and we rewrite this object, we have to rewrite the whole thing. So that's why we're doing this. So over 70 label stats dot over 70 over 60 label stats dot over 60. It's a little bit of a pain, but just bear with me. Over 50 do over 40. And if you don't want to track all of this, you don't have to. You know, you could stop at over 40. But I thought, why not just grab it all? Excellent. Now that we have done that, we can say we want to add one to our count. So we need to let our new label hist value or histogram, and catch all is over 0 for label stats dot over 0. Excellent. Now that we have done that, we can say we want to add one to our count. So we need to let our new label hist value or histogram value is going to equal the prediction score if it's greater than 89, then we're going to say it's over 90. And you can chain these on, because this is a tertiary operator we're using here again. And then I'm just going to copy paste them now. So now, actually no. Prediction score greater than 79. If that's true, then it would be over 80. Now I will copy this, and that's not a comma. They're just chained on. So go ahead and copy. $69, and then that will be a 70. $59, 60. $49, $39, $29, $19, $9. Bloop. $20, $30, $40, $50, and one more that says over 0. Basically, that's our else statement right there. Cool. That is looking good. Now we can say our hist, because we have an object here, and we have the winner of where it falls. So we can say the hist of the new label histogram value is going to be equal to the hist of the new label histogram value plus 1. Excellent. And then all we have to do is return an object that has everything that we want in it. So we want the average precision to be the average precision. We want the overall score. Well, you don't need that. I was doing some testing and I used it, so I'm just going to put it back in. Average precision. In a NoSQL database, it's okay to duplicate the data. So inference count is going to be our current inference count plus 1. Our max will be our max. Our min will be the min. Now, I'm going to put a mean, median, and mode in here, even though you don't really need them. So there's the mean. Median will be 0, and the mode will be 0. We can implement those later. Creating the median moving average was a little difficult because you have to use heaps. And if you're just storing all that in Firebase anyway, I didn't really understand it. So I'm looking for kind of a better solution currently. But also, I don't know if it's that useful to really know. No guess. And then we will spread the histogram. So that's why we ultimately wrote it out, is so that we can just go plop and put it right there. Excellent. Now, last thing to do is say else. And what we're doing in here is we are going to return, because remember, this is saying if it's null, we actually just want to return a value that is totally different from what is saved on the server at this address. And so what we're going to do is we're just going to return 0. This is going to trigger Firebase to refire this transaction if it fails. And it's going to fail because the first time it's going to come up null. So, awesome. Go ahead, save it, deploy. I do deploy all. You can also do deploy only functions, put a colon, and just the name of the function that you want to deploy. That, however, does not work, though, for things like update the label, because it's not an exported one. It's not one of these named functions here, as you can see. So maybe it does get pushed. I don't know. I'll have to follow up with the Firebase team. Excellent. So in our first one, we have it running. If we go to our project, we go ahead and upload a photo. There's our photo uploaded. We can verify that it's uploaded because we have we don't need that guy because that was the misfire. But we have new photos right here. So we do have this photo. We go to our app, we go to the auto inference and see how well it detects things. Bam. Oh, still thinks a trash can's a car. It's a model stats. We're on label stats. Label stats model 1. Yeah, they are working. Look at that. Fantastic. So that all works. Next, we will work on doing the same thing, but for the model stats.